In this lecture, I want to clarify the difference between Apache Spark and Databricks. Apache Spark is the open-source engine you install and run yourself. You pick the versions, add libraries, tweak the settings, and fix any issues on your own. Databricks is a fully managed cloud platform that delivers Spark as a service. It handles all infrastructure provisioning, patching, scaling, and version upgrades for you, so you can focus entirely on building and running your data pipelines without ever touching cluster setup or maintenance. So we can run through a comparison of vanilla Spark and Databricks via this link here. So notice the feature comparison section. So let's go through each of these features. And don't worry if these features are not clear to you yet. We'll cover them as we go through the course. So let's start with Databricks Runtime. Databricks comes with its own pre-built managed Spark distribution optimized for performance and stability. You spend less time on configuration and more time on the data. With standalone Spark, you install and configure Spark yourself. You pick the versions, add libraries, and handle all upgrades and tuning. Next, we have the Managed Delta Lake. So Delta Lake is an ACID-compliant storage layer that brings database-style reliability to your data lake. As I said, don't worry if this is not immediately clear to you what any of these terms mean, as we'll cover them as we go through the course. But the point here is that Databricks offers Delta Lake as a fully managed service, whereas with standalone Spark, you need to install and configure Delta Lake yourself and build any maintenance jobs. Now let's look at this integrated workspace feature. Databricks gives you an integrated web UI for notebooks, dashboards, comments, and built-in version control. With standalone Spark, you need to set up your own notebooks or integrated development environments, file sharing, and Git hosting in order to collaborate. We then have production jobs and workflows. This refers to scheduling, retry logic, and monitoring for production pipelines. Databricks includes a native scheduler with parameterized jobs, automatic retries, dependency chaining, and dashboards. Whereas when it comes to production jobs and workflows with standalone Spark, you need to rely on external tools and build your own retry and alerting as well as monitoring. Databricks also delivers complete out-of-the-box security framework. You get centralized controls, encryption, auditing, and compliance without any DIY work. By contrast, standalone Spark provides no built-in security features. You need to assemble and maintain each layer yourself. Then we have integrations. This refers to ready-made connectors for other services, such as BI tools, messaging systems, and metadata stores. Databricks ships with out-of-the-box integrations, so you can enable these with minimal setup. Whereas with standalone Spark, you need to install and configure each connector yourself and manage version compatibility. Finally, with Databricks, you get guaranteed SLAs and direct help from Spark's core engineers. You get 24/7 support with defined response times, and you can open tickets that go straight to the team behind Spark itself. With standalone Spark, you rely on community forums, Stack Overflow, and GitHub issues. So to summarize, Apache Spark delivers the distributed compute engine at the heart of modern data processing, whereas Databricks packages that engine into a fully managed platform.